As you can see, this is titled Factoring Special Forms. And this may be something that, in fact, I'm pretty sure this will probably be something that you haven't done before, but we really have all of the information we need to be able to factor these. Now, we will start out with factoring things that we do know how to factor. So let me just kind of get us started. Remember, we're factoring here, so let's suppose we have 2x squared minus 8x, and we wish to factor that. Now, when we go about factoring that, we notice, of course, both terms have an x in them. So we know x is a common factor, or some power of x, and we know both terms are divisible by 8, or the coefficients both have a factor of 2. So we recognize that 2 is a common factor and x is a common factor, so we factor the common factor out, and then we create parentheses to put the rest of the expression in. And so 2x times x gives 2x squared, and 2x times negative 4 gives the negative 8x. And so we have it factored. Now I'm going to change this just a little bit. This time we're asked to factor 2x cubed minus 8x to the 4th. And it looks very similar, we just have some different exponents. And so we see that 2 is a factor of 2, and 2 is also a factor of 8, so we know part of our common factor is 2. And we know that x appears in both terms, and so we know we have a factor of x that we need to factor out. And so my question to you is, what power of x are we going to factor out? What's the exponent we're going to put on x to factor out? And I'll bet you'll say x cubed. You know, in the problem over here, we factored out x to the first power. And that first power, if we look at the exponents up here, the exponent of x there is 2, the exponent of the second one is 1, and we factored out the lower power of x, didn't we? And when we look over at this example, the two exponents on x are 4 and 3, or 3 and 4. And so what we do, of course, if you haven't thought about this, is we use the lower powers of those involved. So 2x cubed times what gives 2x cubed? We need a 1, don't we? And 2x cubed minus 4x is how we get negative 8x to the 4th. And so we have factored out the common factor again. Okay, now we're going to change this a bit, and so it gets a little more difficult here, but I know that you can handle it. Now we're asked to factor 2x squared minus 8x to the power negative 1. And so this is probably something that you haven't seen, factoring when we have negative exponents involved. Well, it's the same numbers and the same variables. And here's what I want you to notice. That 2 we can factor out again. 2 is a factor of 2 and also a factor of 8. And since we have x in both terms, then we're going to factor out x to some power. The question is, what power are we going to, whoops, that's a question mark. What power are we going to put on x? Okay, and so as before, we look at the two powers. Power of 2, power of negative 1. What we did in the two previous cases is we used the lowest power of x to factor out. And so which is smaller, 2 or negative 1? And negative 1 is the smaller power. So we factor out 2x to the negative 1 power. Now, here's the next issue, though. So deciding what power to put on x was not a problem. But now we have to take that 2x to the negative 1 power, and we have to multiply it with the first position in the parentheses, and the result has to be 2x squared. Well, the 2 we've got handled, but now we need what power of x, so that when we multiply x to the negative 1 and x to some other power, say negative 1 plus that other power, that questionable power, has to give a 2, doesn't it? So doesn't that mean that the power we need here is 3? X to the negative 1 times x to the third power gives x to the second power, which is what we need to be the result. So we need an x cubed here, so that when we multiply those two together, we end up with 2x to the second power, the very first term above. And then we have the minus sign. And so 2x to the negative 1 times what gives 8x to the negative 1, and of course it's just a 4. So this is the result that we get when we factored what's above. That is 2x squared minus 8x to the negative 1. Okay, let's increase our thought process here. Let's continue. This time we're going to factor 2x to the power 3 halves minus 8x to the power 1 half. So this time our exponents are fractions. But you see what's going to happen here, or maybe you don't see what's going to happen, but we certainly can factor out a 2 again, can't we? And we can factor out an x, but we again have this question, we've got to use the lowest power of x, and the two powers are 3 halves and 1 half. And since 1 half is the smaller of those two, we factor out a 2x to the 1 half power. So here's where we're stuck again. We have two positions in these parentheses. And in the first position, we have 2x to the 1 half power on the outside, and it's going to multiply with that first position on the inside, and the result has to be 2x to the 3 halves power. So once again, we're having to decide what power, see, we're going to have an x to a power right there. What does that power have to be? Well, look, we have to take the exponent 1 half that we have here, plus the power that we're going to have to put on this x right there, and that's got to give a power of 3 halves, doesn't it? So we got to figure out what that must be. Well, it must be that that question mark has to be 2 over 2. 1 over 2 plus 2 over 2 ends up being 3 over 2. And of course, 1 over 2 is nothing more than 1. 1 half plus 1 is 3 halves. So this exponent has to be a 1 so that we get the 3 halves exponent above. And then 2x to the 1 half times what is negative 8x to the 1 half, of course, a negative 4. Now, obviously, we would write that as just x minus 4. We wouldn't put that exponent of 1. So if we multiply that out, we'll see, of course, that we get 2x to the 3 halves minus 8x to the 1 half. So this certainly does look different than what we've seen in the past. Well, on the next page, let me pause as we go to the next page. Okay, now we get into a real factoring problem, a real issue. When I say a real factoring problem, and of course I'm going to read it, but you see it. We're to factor 2x minus 1 to the power 3 times 2 times x minus 3 plus x minus 3 to the power 2 times 3 times 2x minus 1 to the power 2 times 2. Now, notice for us to start on this, we need to kind of look at the big picture. And everything in here, I mean, everything outside the parentheses here is multiplication. So this might be like maybe a 5xy or something of that nature. It's all multiplication. This sign plus separates the two terms, if you will, because all of this is multiplication. So we kind of think of this as like a 2x plus 4. And that plus is the plus and the 2x plus 4. We have the things in front of the plus and the things behind the plus. Now, the next thing we notice is that it's just, there's a lot of stuff. And the first thing I would end up doing here before I start factoring is I'd spend a little bit of time cleaning it up so that it's more pleasing to my eye and I recognize things. And the way I would start up is in this first part, I see I have a regular old number 2, and we'd really like to put those kind of in front. So I'm going to put my 2 in front, and then my 2x minus 1 to the third power, and my x minus 3. And then I have the plus sign. Now in this second term, we see that we have a number 3 and a number 2 in the multiplication, and we know 3 times 2 is 6, so I'm going to write 6 in front. Now here's something else I'm going to do. That as I'm looking at this, x minus 3 squared, well, I have an x minus 3 in the first term. and 2x minus 1 squared, I have a 2x minus 1 in the first term. What I want to do is I want to write these in the same order just to help myself. So since 2x minus 1 is in the beginning in the first term, I'm going to write my 2x minus 1 first in this case. Of course, the exponent's 2 on it. And then I have an x minus 3, that's the second factor over here, actually the third, I guess. And so in this second term, I'm going to put my x minus 3 in this position and a square on it. So at least now I have number times 2x minus 1 to a power times x minus 3 to a power in both cases. They're in a nice order, and it makes it easier for my eyes to see what I'm doing. Now, remember, this plus sign is separating the two terms. And so to factor this, we look at the numbers 2 and the number 6. Is there a common factor there? And of course, the answer is 2. So we can factor out a 2. That's a common factor between 2 and 6. Then we notice that 2x minus 1 appears on this side of the plus and also on this side of the plus. So 2x minus 1 is a common factor. But when we have a common factor and they both have powers on them, we use the smaller of the powers. So the factor we're going to factor out is 2x minus 1 to the power 2. And then we look at this x minus 3. And there's also an x minus 3 over here. So x minus 3 is a common factor. And the lowest exponent between the two choices is 1. So rather than putting an exponent of 1, I'm just going to leave the exponent off. Now, to illustrate, see, this is the common factor. Before it wasn't so complicated, but that's the common factor that we're factoring out. So what we normally do is then we create our own parentheses, but I'm going to create brackets, see, because now we're looking at this plus separates what we have inside. And so all of this has to multiply with the first term to give the first term that's up here. So we already have the 2, but we've got a 2x minus 1 to the second power down here, and we need a 2x minus 1 to the third power there. So we need to have a 2x minus 1 to the first power. Second power multiplied with the first power gives a third power, doesn't it? And x minus 3 times what? Well, we already have an x minus 3, don't we? So that's the only part we need in this inside these brackets to get the first term above. Now we need to take all of this greatest common factor and multiply with what goes here to get all of the second term that's over here. So 2 times what gives 6? We need a 3. 2x minus 1 to the second power times 1 gives 2x minus 1 to the second power. So we don't need any more 2x minus 1s. But we have an x minus 3, and we need to multiply with an x minus 3, so we get that x minus 3 to the second power that's there. Okay. Now, let's kind of clean this up. Let's go the line below, and let's write out in front our common factor, 2 times 2x minus 1 to the power 2 times x minus 3. And inside these brackets, let's see what that simplifies to. In the first place, we have a 2x minus 1. And in the second place, when we multiply that 3 out, we have a 3x minus 9, don't we? And 2x minus 1 plus 3x minus 9 can be simplified to 5x minus 10, can't it? So we have the 2 here, the 2x minus 1 to the second power times the x minus 3. And now, since I don't have parentheses inside, I can go ahead and change those brackets to parentheses. And when I simplify inside, I have 5x minus 10. And then I do notice that 5x minus 10, we can factor out a 5, can't we? See that 5x minus 10, we could write as 5 times x minus 2. So we have a 2 times the 5 that we're factoring out times 2x minus 1 squared times x minus 3 and times an x minus 2. And of course, we could write that as a 10, couldn't we? So this is 10 times 2x minus 1 squared times x minus 3 times x minus 2. And of course, that's still kind of complicated, but it certainly looks better than what we had in the unfactored form above. Okay, I want to do one more that's kind of complicated like this, and that's all of the special factoring forms that we'll look at, and we'll go on to something different then. Okay, we have another complicated expression that we're supposed to factor. And I'm going to spend time like I did in the previous problem by kind of rearranging it and making it a little easier for my eyes to follow. And the way I'm looking here, I have a monomial in front. I don't have any extra numbers, so that's good there. I have a 7x plus 3 to a power and an x squared minus 2 to a power. But over here, of course, I have a number, and I have these two binomials in a different order. So I'm going to write them in the same order. I'm going to rewrite this as x times 7x plus 3 squared times x squared minus 2 to the power negative 1/2. And then I'm going to say plus 7, and I'm going to put my 7x plus 3 before my x squared minus 2 to the power 1/2, because that's the same order I have in the first term. Now, as I look through this, we'll kind of go off like we did a moment ago. We look at these monomials, and there's no numbers that are a common factor to each, and there's no powers of just plain x that are a common factor to each. And so we don't have a x power or a number to factor out. But what we do see is that we have 7x plus 3 occur here and also here. So that means 7x plus 3 is a common factor. Now, in the first term, the exponent is 2, in the second term, the exponent is 1, and so we use the smaller of those two exponents. Then we notice that x squared minus 2 appears here, and it also appears here. So x squared minus 2 is a common factor. And in this case, one of the exponents is negative 1/2, and the other is positive 1/2. And so we have to use the smaller of the two exponents, and so we have to use the exponent negative 1/2. Okay, so this is the common factor, as we had before. This is just really my note to you. Okay, that's the common factor. And when we factor out a common factor, then we create our own parentheses. In this case, I'm using brackets because we've got to put stuff inside. Now, notice, again, like we did before, our common factor times the first term has to give us our first original term. And so we know that we have to have an x in our first original term, and we have to have a 7x plus 3 to the power 2. Well, we've only got a 7x plus 3 to the power 1 in our common factor, so we need a 7x plus 3 to the power 1 again to give a power 2. And we already have x squared minus 2 to the negative 1/2 power, so we don't need any more x squared minus 2's. Now, when we look at what goes in this position, remember we're needing to multiply our common factor with this position to give us what we have right here. Okay, so we've got to have a 7 alone because we don't have a 7 in our common factor. So a 7 has to appear when we multiply. And we have a 7x plus 3 in our common factor. We don't need an additional 7x plus 3, otherwise we'd create a power greater than the one that's already there. So we don't need any 7x plus 3's. But our x squared minus 2, we have to the negative 1/2 power. And so we're going to multiply with an x squared minus 2 with some power, so we get that power of 1/2. See, that's the whole idea here, is that we're going to have an x squared minus 2 to the power negative 1/2. And we've got to have an x squared minus 2 to some other power. So when we multiply them together, we get x squared minus 2 to the power positive 1/2, because that's what we need up there, isn't it? When we multiply it out, we have to have a resultant power of 1/2. So we have the power negative 1/2. We've got to figure out what exponent we need. So when we add negative 1/2 and that exponent that is unknown yet, it has to be a positive 1/2. And we can actually go about this by just saying, well, we solve this. That is, why don't we add 1/2 to both sides so we can get that question mark alone? So question mark is the 1/2 that's over here plus the 1/2 we're adding to both sides. And so our question mark ends up being just 1, doesn't it? That means this exponent right here needs to be a 1 exponent. There's no longer a question mark. Okay, so we take that information. Let's get down here below where we've got plenty of room. We have 7x plus 3 to the power 1 times x squared minus 2 to the power negative 1/2. And inside these brackets, we have x times 7x plus 3 plus 7 times, and I'm just going to write x squared minus 2. We don't normally put a power of 1s, and when we put a power of 1 on parentheses, it kind of confuses us. Can we multiply it out or can we not? Inside those brackets, there's still things we can simplify. So we write down our common factor again, 7x plus 3 times x squared minus 2 with a power of negative 1/2. And inside these brackets, x times 7x is 7x squared. X times 3 is 3x. And over here we have 7 times x squared, so that's 7x squared. And 7 times negative 2, which is negative 14. So we have 7x plus 3 to the power, to the power 1 times x squared minus 2 to the power negative 1/2. And inside those brackets, we can simplify. And we don't need the brackets. We'll go ahead and replace those with parentheses. 7x squared plus 7x squared is 14x squared. And we don't have anything to combine with the 3x. And then we have a minus 14. And I don't think that we can factor that any further. In fact, I'm pretty sure we cannot factor that trinomial any further. So this would be our final answer in that factorization. Now this, like I said, this is probably something that you haven't done before, but we will be using these ideas later in the course when we start talking about the calculus portion of this. Well, that's all of the special factoring forms that I want to do. So we'll stop this lesson and start another type of lesson here in a bit.